11.6 probability with not, or, and odds. We're going to have several videos. First of all, if you haven't already been introduced to a deck of cards, we're going to talk about this. A deck of cards has 52 cards. There are 13 different values of the card: ace, 2, 3, 4, 5, 6, all the way down to jack, queen, king. That's 13. You can count an ace as a 1. Some card games place an ace before a 2. Some place the ace higher value than a king, but that's really not important for probability. The important thing is we have 13 distinct cards. 4 suits. These are called spades, clubs, diamonds, and hearts for obvious reasons. 13 times 4 is 52 cards. The jack, queen, and king are called picture cards. There's pictures of a jack, a queen, and a king, actual people on the cards. That's why they're called picture cards. The rest of these are not picture cards. So as far as doing probability with a deck of cards, we have 3 possible sample spaces. It can have the 52 cards itself, or it can have spades, clubs, diamonds, hearts. It all depends on what type of a probability problem you're trying to solve. But spades, clubs, diamonds, hearts, equally probable because there's 13 of each. We also could do ace, 2, 3, all the way up to jack, queen, king. That could be a sample space. Here's some elementary problems. One card is drawn, find the probability of drawing a club. Well, if you use this sample space, there's a club right there. The answer is going to be, I need my black marker, 1 out of 4. Now, incidentally, if you use the whole deck of cards, there are 13 clubs out of 52 cards. So you would say 13 out of 52, which reduces to 1/4. Different methods should always give you the same answer. Probability not a club, you can calculate this directly. Not a club is spade, diamonds, or hearts. That's 3/4. But there's also a rule we can do 1 minus probability of club, which is 1 minus 1/4, and 1 minus 1/4 is the same as 3/4. So I believe all the problems here you can use these complementary probabilities, or you can just calculate them directly. And incidentally, it would be 39 out of 52 if you use the larger sample space. 2 or a 3, okay? Calculating it directly, that's 2 out of 13. And of course over here, there are 4 2s and 4 3s, 8 altogether. You can calculate that is 8 out of 52. And you can divide 4 into the numerator and denominator, and it gives you 2/13. Probability of the 10 of clubs. 10 of clubs is right here. Guess what? There are only one of them. If there are 2, the poker player you're playing with is cheating. So 1 out of 52. Notice in this case, our only choice is to use sample space number 1. For the simple reason, 10 of clubs does not appear here, does not appear here. It's not a choice in the sample space. 3 or a club, a little trickier. If you go over here, there are the 3s, there are the clubs. You can count them up, 1, 2, 3, 4. Count this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And what's 4 plus 13? Is 17, but don't be so hasty. Guess what? We added in that card twice. So you can count 4, and then it's really 12. You have to skip over that. 4 and 12 is 16. And so 3 or a club, we get 16 out of 52. And I could divide 4 into that. 4 goes into the top 4 times, and 4 goes into the bottom 13 times. So it reduces to 4 over 13. So that's all for basic probability with a deck of cards. For the most part, most of the problems in the assignment are just a matter of counting and dividing. Or means it can be one or the other. So you just have to be careful here. If you have something fits both categories, you have to make sure you don't overcount. We'll be back. We have some other probability questions dealing with or, and we also have odds coming up as well.